Roll. Let's get this done. We're gonna do all 4 of these problems together, and then I got one for you to do on your own. On the left-hand side, we have circuit 1 over here on the left. We have circuit 2 over on the right. Which one is in parallel, left or right? Left is in parallel because there's a split in the wires. Number 2 is in series because there's no split in the wire at all. What we're going to look at today is these things mixed together. I'm going to go to the exit ticket real quick. This is what we're going to do when we leave. We have, these are in parallel, these are in series. We're going to learn how to combine them together. So let's just do these examples one at a time. Ooh, I don't want that. I want to keep my dark screen here. Let's clone this guy. My page. Oh snap! I'm ruining my life. Okay, hold on a second. Give me a moment here. Yeah, I feel like I should start the whole thing over. All right, let's do this. So on number 1. We're looking at this. On number 1, what do you see there? Is that series or parallel?
Oh, parallel. Series. It's both, ain't it?
It's only one. The question is basically, is there a split in the wire anywhere?
No.
There's no split in the wire. There's no split in this wire, so this is in series. That means it's a really easy problem. Our total for a series circuit is this. Our total is R1 plus R2 plus ... That means I just add them all together to get our total. The question is asking calculate total resistance, so it's an addition problem. Welcome to 2nd grade.
18 plus 8 is 26, 26 plus 12 is 30.
So 18 plus 8 plus 12 plus 8. You have to show that work. You have to show the entire equation. 18 plus 8 plus 12 plus 8. Otherwise, I might think you copied off your bro. 46?
Yeah.
46 ohms. Circle that answer. 46 ohms. That's supposed to be a horseshoe shape. Don't look very great. Okay, 46 ohms. There's our answer. Now, the thing with these problems, it says calculate total resistance and draw the equivalent circuit. That means these 4 light bulbs, maybe they're light bulbs, these 4 light bulbs have a total resistance of 46 ohms. That means that if we had one light bulb with a 46 ohm resistance, it would be the same as this circuit. It would have the same voltage, the same current. Long story short, we got to redraw it as one resistor, like this. 46 ohms. That's what it means by redraw. You don't redraw, you don't get your full credit. So these 2 circuits are going to have the same voltage. They require the same amount of power, same amount of energy. They are equivalent. That was too easy. Let's take it up a notch, yeah?
No.
Too bad! Calculate total resistance and draw the equivalent circuit. Let me sketch this for our viewers on the YouTubes.
Oh, I thought, bro.
Are you guys being mean to each other back there? Are we okay?
I was drawing.
Alright, I won't be able to...
Goofy. I'm not just military. I need to.
Definitely are.
So did you just correct it?
Alright. Alright. It's supposed to have ohms. I can't fit that. So we have 5, 10, 15. How are they connected? Series or parallel?
Parallel.
Yeah.
Parallel, because of the split in the wire. That means to get our total, we need to use this equation. Since it is a parallel circuit, we need to use the equation that corresponds to parallel circuits. So 1 over R total equals 1 over R1 plus 1 over R2. On your equation sheet on the test, you'll have 2 sets of equations. It'll say series, it'll have that equation from number 1. You'll also have a section that says parallel, and it'll have this equation on there, among others. So let's do it. 1 over RT equals 1 over 5 plus 1 over 10. Right, plus 1 over 15. This dot, dot, dot means you add until you have everything you need. 1 over 5 plus 1 over 10 plus 1 over 15. What do you think, guys? Do you want to get the greatest common denominator?
No.
I don't want to do that. That takes time. So let's just type it in our calculator. Yeah, greatest common denominator is 15. You can go ahead and do that. It would be like, that'd be 3 over 15. I don't know how to do that one. Either way. Oh, probably 30, yeah. Point. But we've got calculators to do that legwork for us. We like decimals anyway in physics. So in your calculator, you could type this straight up. 1 over 5 plus 1 over 10 plus 1 over 15. If you're using just the calculator app on your phone, might not work unless you've got like a graphic calculator app.
0.367.
0.367?
Yes.
Cool. .367. Yeah, on the left-hand side, we still have RT, so we'll have to cross-multiply. I think yellow is going to look cool on here. Ooh. Get some turquoise.
Can't see.
Good vibes only. You're breaking rule number 1. 1 equals 0.367 RT. What's my last step? Divide. Awesome, awesome. 2.72 ohms. But we're not done. What do we got to do? Got to redraw. I think convert's an okay word.
Yeah.
Convert to an equivalent circuit.
Yeah.
That's a reach.
What was it again? 2.67? 2.72 ohms. So here's our equivalent circuit. Woo! Fun times. You're right, guys. This is too easy. Let's take it up a notch again. Don't be frightened. We'll be okay.
Before you can go.
So we haven't even gotten to today's lesson. Now we're at today's lesson. Number 3 and 4 are what I consider to be complex circuits, because we have very odd connections here. What color am I using? Okay. All right. This is number 3. when solving complex circuits. The tip I have is do your series connections first. Do your series connections first. So we have a bunch of resistors up here. Which two of these are in series with one another? 12 and 14. 12 and 14 have no split between them, so they are in series together. Those are really easy to do. So we're gonna call our shot. We're gonna circle what we're working on. We're gonna work on those guys. This is the easy equation. R total is R1 plus R2 plus whatever. For series connections, you just add them together. So 12 plus 4. Yep.
14.
Oh, 12 plus 14, my bad. So we'll have 20. Yeah, 12 plus 14, 26 then.
26.
And the directions tell us redraw the reduced circuit each time you use an equation. So we're going to have to redraw this thing. You're going to have a total of, including what's there, you'll have 3 pictures. So we're going to redraw only 2 times. So if you go sideways across the page, you'll have enough space to do both of them. So I'm going to try to make this a little smaller. I'm going to color code too. Let's make this yellow. That yellow one is the one we're going to replace. So on the bottom it's still 10. This is still 10. But when we combine these two, they are just like a single 26 ohm resistor. So that's why we're redrawing it. So now we have a new picture to work on. We'll have to do it again. Yep, we'll have to do something slightly different. Are those 26 and 10, are those in series or parallel? Parallel. So we'll have to use the parallel equation. I'm going to clean up, give myself some space, move this guy off screen for a moment. Whoa. We'll come back to him. We won't delete him forever. So we're going to have a new drawing. I don't even need this work. Find a way to organize your space on your page. Okay. 1 over RT equals 1 over R1 plus 1 over R2 plus whatever. Because it's in parallel, we use this equation. 1 divided by RT equals 1 over 26 plus 1 over 10. We don't need to mess around with greatest common denominator. Just type in your calculator. 1 over 26 plus 1 over 10. Okay, so I heard 0.138. And on the left side, I just have RT on the left. What remains on the left-hand side? 1 over RT. A lot of people will forget the 1. A lot of people just write RT and call it a day. But no, we've got to cross multiply. It's a whole thing, man. So we'll do that. I need a different color for this. Cross multiply. There's an invisible 1 down here.
7.25.
Awesome. Divide both sides by 0.138, and like you guys said, 7.25. Thank you. 7.25. This is our second equation, so we're going to have to do our second drawing. So there. Resistors slow the flow of current. So this original picture that we had, this will slow the current the same as a 7.25 ohm resistor would by itself. So these work together to create a total resistance of that. That's how much they slow the battery's push.
Wait.
Last one. We got out of here at 9:55.
Yes.
Awesome. You guys will have plenty of time. Sure. So this. I need to clone my page. Okay, last one.
So that was it for the last part?
Yeah, that's the whole problem.
Number 4.
Anybody remember my tip from last time? It was which should we work on first if we have the option?
Series.
So usually we should work on series first. For those of you that said parallel, I think you were a step ahead of us, which is right. Here, there are no series connections. We can't do anything in series here. So now that that's off our list, we have to go to parallel. So try to condense any series connections first. Since we have no series connections here, we're going to work on that parallel set. Which two resistors are in parallel? 10 and 6. Let's go. 10 and 6. We're getting the tough part out of the way. The messy equation. One over RT equals 1 over 10 plus 1 over 6. So in your calculator, you should type in 1 over 10 plus 1 over 6. 0.267. Thank you. Again, we cross multiply. It's the same old stuff. RT. Divide both sides by 0.267.
3.75.
175. I'll wait a moment for people that still need to write that down. Then we'll go and redraw. Try to redraw it on your own if you're already done with this. Remember, redraw for every equation you use. This is our first equation, so we'll have our first redraw. I want to use a different color. I'll go for it. Living life on the edge. So this is still 8 ohms, and our new resistor is 3.75 ohms. Again, these have their own resistance of 6 and 10, but when they're working together, they only have a resistance of 3.75. So when you put two resistors in parallel, they don't really stop the flow of electricity very well. They don't work together as a team very well. And our last connection there, what kind of connection are we looking at? That's a series, that's easy. So we'll just add them together.
Shut the front door. Oh, shit. One woman said.
11.8.
11.8 or 11.75. And we'll redraw. I don't have space to redraw. I'm gonna go, whoops-a-daisy. Fine, I don't want my work on here anyway. I'll just leave it. So our final answer is here, 11.75 ohms. Y'all have 15 minutes to try out this last one. Yes.
Can you go back for that? How would you know which side to leave it on?
Yes.
An S.
Like on the bottom or on the right?
Yes.
It actually doesn't matter.
Okay.
Either one.
Quick question. Oh, no. They said they should be on the red line. Jump at 79. Why?
You know, I'm realizing something. I don't like my own rule. I told you that rule of do series first, but really, the thing that you. Let me just show you one last thing. This will be important to know. So the do series first thing doesn't really make much sense, but basically here's what I'm trying to avoid. In this case, this is a case where you have to do series first. Like before you condense down here, you got to combine those two.
Yeah.
But in other cases, it kind of doesn't really matter. So that's all I'm trying to avoid. So here, actually, on this example, it's going to be easier to do parallel first. Yeah, so you'll start with these. So I do this on separate paper. You're going to turn this in on your way out. Do this on separate paper. I'm going to draw it because, actually, I'm going to just stop the video. You watch and you don't have to do it. You're all okay. If you weren't here today, you don't have to do it.